Good afternoon. I'm Robert Gezelter. I'm going to be speaking today on using OpenVMS shareable libraries to reduce footprint and development expenses and maintenance expenses. Thank you for coming. Most applications programmers are used to writing code as a big blob that gets linked into an image and then run. However, VMS offers an option which substantially simplifies development and maintenance and gives us a tremendous amount of flexibility. Shareable libraries have been part of VMS since release 1.0. They allow you to use large amounts of external code without putting all of it into your binary image. For example, the VMS runtime library, including RMS, is just a large shareable library. If you were to link, say, a simple Fortran or C program with all the modules included that are referenced, the result will be hundreds of blocks long. But if you take your typical hello world program in any major language and compile it and link it, you will discover that it generates half a dozen or a dozen blocks of image. The rest is included dynamically at image activation time by the image activator from the system library directory. However, this is going to be used more extreme. Not only is it available to VMS, the VMS team for the runtime library, it's obviously available in other contexts. For example, if you build against live SSL, you can build against a shareable version. If you have your own common set of tools that your program uses, you can build a shareable library with those tools and then link them at image activation time into any image you build. You can do that as a management technique without any privileges, or with privileges, you can install the shareable image, and the same copy of the read-only library will be used by all users of that library. This can have significant impacts on memory consumption. In one client case many years ago, we went from a 4-user situation with full memory to more than 100 without a problem, because the program they were running was megabytes in size for each user, but the vast overwhelming majority of that code was fully shareable. So we were able to share the library, share the program, and reduce the footprint to a fraction of what it had been otherwise. Huge benefit in performance, huge cost savings in capital. If you use a shareable library, you do not need to relink every time the shareable library is updated. The main program is also smaller, so the link is faster. This may seem like nothing, but on an original 780, I had links which took 25 minutes to half an hour to run. When I switched most of the libraries used, granted, these were huge libraries, when I built a shareable image and linked, the link time went down to below a minute. You can also, when you update, only update the shareable library and restart the program. The image activator will do all your dirty work for you. For speed and efficiency, you install the shareable image and you gain one copy of the read-only code and data. Writable material is handled by copy on write pages. Reduce the memory footprint. That improves the total number of people using memory. It improves, in some cases, caching. And also, you save a lot of disk space. Now, a lot is relative. In those days, we were talking about disks of 160 meg. Today, we're talking about terabytes of disk space. But the reality is that caches, space is space. repetitively moving the same data around has a cost. And every little bit counts. I have seen sites go through huge debugging cycles and troubleshooting cycles trying to find why something malfunctioned, only to discover that of a population of hundreds or thousands of images, a handful got missed during an update. If you update a shareable library and everybody religiously uses the shareable library, there is no mass relink required. You just shift the logical name pointing to the shared library and reinstall a new version. This also allows you to do an update and stage the update one user community at a time so that you can control how many support calls you're fielding if there is a problem. A huge benefit in dealing with upgrades and potential side effects. There are also other ways you can use libraries. If you have a library for a defined interface, you can also have two versions with different end results, but they plug into the same place, much like a power cord plugs into a regular AC outlet. More on that in a minute. Such an approach has been used for more than half a century on various platforms. It is highly efficient. It gets rid of if statements and cases. It's expandable. The code burden is tremendously simplified, and so forth. Why? Shareable libraries get you efficiency, performance, maintenance, and change control. You get rid of regression problems because you know everybody got relinked. And in effect, you cut manpower and man-hour needs in doing upgrades. If you have a collection, if your code for a particular project is broken into pieces and each one is a shareable library, you can have multiple people working on different parts of the source base and work creating their own test and pre-publication copies of the shareable library, which can be used by other developers. If there's a problem, the other developer can revert to the original version to see if there's a problem. Much less muss, much less excitement. A shareable library is a piece which is dynamically linked in at image activation time. You do not need privileges. I have done this with classes for students. It's a simple set of commands. No privileges required. All you need is the usual non-privileged user privileges and access permissions you would give any undergraduate student taking a programming class. The only requirement is that it conforms to the linkage rules. Otherwise, your imagination is the limit. You can put data in a shareable library. For example, you could have information, basically a table that is compiled in some way, made a shareable library, and pulled in to each of the users. The data should be marked in general no write to avoid race conditions, or copy on reference if you're going to use it as a base for a starting point in some data structure. When you call a shareable library entry point, your call goes to a transfer vector, which then directs it to the actual entry point. If the components in the shareable library change, the transfer vector, which is part of the shareable library, will be different. The customer of the shareable library, the caller, only knows the vector offset into the vector. Therefore, from the perspective of the outside, there is no change to the shareable library. You can use multiple shareable libraries at any point. We use 15, 20, 100 shareable libraries. not counting the VMS supplied shareable libraries. And what you need is the limit on your use. All you need to do to specify a shareable library is define a logical name that you use to reference the shareable library, and the actual user will invoke the program. On Alpha, x86 and Titanium, in the linker options file, you use the symbol underbar vector command to define each of the vector entry points for the shareable library. You save link time, you save disk space, you save maintenance effort when there is an inevitable change in the shareable library. You get to manage things, you get to deal with eliminate regression errors, and you get to control the pace of update. Some pointers and suggestions, which are not necessarily in the documentation. It helps to have a divide ID entry point in each shareable library that returns a pointer to a string, giving the version number of the shareable library. This way, you can produce debugging output of which, when a program fails, you can have the program ID what versions of the shareable libraries with calls were involved. Be careful when you have multiple versions. It is easy to get confused. If you do shareable, writable data, please be very, very careful. If you don't synchronize for multiple threads, multiple processors and the like, you will be sorry. Enforce that people use the libraries rather than linking in the objects. Seriously consider making object libraries protected to no read to the general world except the maintenance team for that library. You don't want somebody deciding to bring the object library in instead of using the shareable. You'll spend a lot of time looking for the bug that was actually 10 versions old because nobody relinked the copy. Concepts are simple. Transfer vectors provide upward compatibility. Most data is as writable is allocated in the stack or in main memory or copy on write pages. Normal use doesn't require privileges. If you want to share things, you need to install the item as shared. Back when we were worrying about macro 32, the danger was move # some address constant to a register. That is an impure reference. That will prevent that from being shared. Use move in macro, use the move A instruction as a substitute. That solves the problem. Also, in higher level languages, the compiler backends do this for you, so it will not happen. Watch out for certain things like Fortran commons, external variables in C, and similar structures. Make sure the compiler is producing no write references or non-shareable. Watch your psect attributes. Yes, I'm giving the presentation for the record into the teams. Be careful of shareable and write, you will hurt. Linker issues. You need the /share switch on the linker. Watch the GS match parameter. If you do it correctly, you will work with later. It's a minimum of what is required before using the image. If you let the linker pick the default, you will have to relink the moment you make a change. Be careful with psect attributes. It is worth pulling the link map and taking a look. It'll be far less surprising that way. Make sure when you do a link periodically, check the map file to verify everything is as you think it should be. Debugging is easier before you release a shareable image, but you can use the debugger. Also, local logical names override more global logical names. Remember the hunting sequence? It starts at local, then goes to job, then goes to group by default, and then goes to system. You can change this. See my article on logical names in the former OpenVMS technical journal. There's also several presentations on that, and there are several blog entries relating to logical names and shareable images. And there's also a white paper. All of these are available on my firm's website at rlgsc.com under presentations and publications. We have two examples. First, a program that required, granted this is an outdated metric, I only worked on this many years ago. The link took over 20 minutes on a VAX 11.7.8. The library in question had hundreds upon hundreds of modules, which also had hundreds of calls between modules. It was large for the day. The link took 20 minutes. And that wasn't a very loaded machine at the time. And you looked at it, it was a pyramid. You had a main program, which is about 150 lines. There would be user-written subroutines that were huge. It was a graphics package. There was a bunch of locally developed routines that were needed, vendor supplied routines. Then you had the Fortran runtime library and the OpenVMS runtime library. It's a pyramid. By linking the user-written routines and as a separate entity, I was able to reduce the link time to a couple of seconds. I ended up with a well over 1,000 block shareable image, but the transfer vector had all the relevant entries. Basically, it was two things. Tech plot, as the name implies, was tectronics plot. It was huge. This is not the scale. The VMS RTL, which included in those days the Fortran RTL, and the main program. Simple link. Just assign techplot.exe, the simple tech plot, run the program. Bang, done. Case 2 gets interesting. Remember, every library call is basically an API contract. So if you have something, a task which has many variations, it can have different output formats, it can have different selection criteria, it can have different sub-processing done before the output formatting is done. You end up with large numbers of variations. For example, this system is a mailing list system for a nonprofit. It had to generate from a common database labels, envelopes, form letters, invitations, listings, and attendee lists, and various other things. The client kept coming up with new things as fast as I could swat the flies. Obviously, if you follow a conventional programming model without shareable libraries, you have basically an exponential function. A times B times C times D dot, dot, dot. If you expand the math, if statement, well, first of all, if statements are bad. You can't add enough if statements if you're still modifying the program every time somebody comes up with a new variation. That's bad. However, it turns out all the possibilities generate a collection of choose some number of items from each category. There's record processing, initialization, processing, and end. There's an accept routine to decide that if a record is yes or no, we process this record. there's a name builder, take a record and produce an addressee name or an addressee line. There are various utility procedures and various processing routines. So it is like you take out Chinese restaurants menu. You can have chow mein with chicken, beef, pork, shrimp, etc. You can have lo mein with the same thing, choices, and so forth. It's pick one from column A, pick one from column B, and 3 from column C. Also a family dinner. What does this look like? Well, if you multiply these all out and hard-coded everything, you'd have 35 times 30, which works out to be about 1,000 programs. That would be a mess. And remember, every couple of days, somebody is adding another choice. If you look at the components, you get 5 components. Well, you can do this with 43 modules. One for each of the categories we identified, one from each of the subroutine groups we identified, plus the main program. If you do it conventionally, it's 1,050. If you do it by pieces, it's basically 43 with 3 interfaces. That's a lot smaller. And this is what you get graphically. You get a couple of attachment points and various plugins that plug into said attachment points. You pick your choices, you assign the logical names to the choices. Well, the choices to the logical names, to be exact. And you get to achieve the equivalent of lots of if statements with a handful of lines of DCL. Remember, you can also use this as a way to have a library of commonly used modules, and users or groups can write their own modules to the same specification and use them. It's a very flexible, very distributable concept. It's a menuing system. Very easy to write DCL using things like the locate lexical function and check using file verifies to make sure the pieces are where you think they are. It's as simple as can be. The complexity is obviously not exponential. You build applications, particular instances of applications with simple building blocks that are vetted against a common standard. Thank you very much. I will be available here and afterwards for questions. Thank you for attending.